Hi there, this is Jacob Nash Engineering Lessons. This is Unit 2.1, and this is Lesson 10, and then this video will show you how to solve Activity 2.1.4 on vectors. So, let's get started. First question that we have is we're trying to find the magnitude, direction, and sense of a vector. Let's draw it. So it's not going to be the best drawing, but you get the idea. So here's the vector in red, and it has 9 newtons, and then this angle is 30 degrees. Okay, so first let's find the magnitude. That's easy. It's 9 newtons. That's what it is. It says. So you don't even have to do anything. Magnitude equals 9. Well, I'm going to say MAG, not just M, because just M stands for moments in this unit. I don't want you to get confused with that. That will be next lesson. And then now, what is the direction relative of vector A? I forgot to label that. This is vector A relative to the negative y-axis. So this is the positive x. I talked about this in the last video. This is the negative x, positive y, negative y. Because remember, up, positive, right, positive, down, negative, left, negative. So negative y-axis because it's down. So the direction relative to negative y-axis is right 30 degrees. Why? Well, it says 30 degrees for one thing, but it's to the right of the y-axis. So that's what that is. And then the sense is going to be the literal direction, and that would be down and to the right. So I'm just going to use arrows down and right. That's what it is. So now we need to find the y and x components. Well, let's see. How do we do this? I didn't explain how to do this in the last video, but I will explain how to do it in this video. So let's use blue right here, and this will be the y component. And remember, I said in the last video, y component can be represented with Fy. Then the x component can be represented with Fx. Let's try to find the x component first. So we need to use SOHCAHTOA in order to find the x and y components. SOHCAHTOA. So let's separate this so we can see. What will we use? Will we use sine, cosine, or tangent? Well, it depends on where the angle is relative to Fx. So we know this is opposite to the the angle is opposite to Fx. And so therefore we need to use sine. We're not using tangent because there is no use to do that because we are not looking for, this would be the adjacent, and that's not something that's being involved. We can't add Fy when we don't know what it is. So we use sine. Now, in the case of many problems, for Fx, you use sine. But this is not always the case, so keep that in mind. So our formula is force times the sine of an angle represented with theta. Okay, well, the force is 9 newtons times the sine of 30, because that's our angle. And that's all we have to solve for. And that is approximately 4.5 newtons. That's the unit, newtons. And it's positive. Why did I say positive? Because the direction that this is going is to the right, and we said right is positive. If it was going to the left, then we would say negative. That would only be if it was over here or up here. So, when you're typing this in a calculator, you should type it like I did. Parenthesis, 9, close, open, sine, and it will already bring up a parenthesis. Type in 30, close it, and then close another one. That's how you have to do it so it turns out right. Now let's find the y component. We will use cosine this time. So that's the formula. And y is because this is adjacent to it. So adjacent A. Now that is going to be pretty much the same thing, except for you just replace sine with cosine as far as plugging things in goes. And we will get 7.8 approximately newtons. Negative, though. Why negative? Because this is going down. That's the way that this is going, down. And down is a negative value. It's at the negative y-axis. If it was up here, it would be positive. So, now we have the x and y components. Let me see, is that all we had to do for this one? Yes, that is. That's all we had to do for this one. There's a more complicated problem where we use those even further. I apologize if this video turns out to be long, and I am expecting it to be, because I don't know how long this has been recording, but that was only the first problem, and it took that long. But even though it takes me long, it shouldn't take you that long, because you don't have to explain, you only have to solve. So now we have vector B, and let's label that 30 degrees, and it's also 9 newtons. So it's the same values, just pointed a different direction. That will change things. Don't think it's going to be the same answer, because it's pointed a different direction. Some things will be not the same, negative or positive. So this is vector B. Now we do the same thing. First we find the magnitude. That is 9 newtons. We find the direction relative to the negative y-axis. That is left 30 degrees. So that's different. Left is a negative value. That hints on to how our answer would be different. Then the sense is down and left. That's both negative values. So honestly, that means, remember, last time we got 4.5 and 7.8, and 7.8 got negative. This time, they're both going to be negative because of this. So if you're experienced with this, you could already know that's what the answer is going to be for finding the x and y components. But for this purpose, I will still solve them out in case you didn't understand. So Fy, once again, this time Fx is over here. To find Fx, we use either sine or cosine. We're going to use sine because it is opposite to the angle. So we will do, remember, it's force times sine of angle. So that is going to be 9 times the sine of 30, which is 4.5 newtons. Once again, like another problem, but this time negative, like I said, because it is left. That's why. It's negative. And it does matter if you do negative or positive, so keep that in mind. Then we're going to use cosine for finding the y component because the y component is adjacent to the angle. Adjacent, by the way, just means beside it, basically. So 9 times cosine of 30. Once again, 7.8 doesn't change. Newtons. Negative, though, because it's down. Down means negative. So now we found both. Now we're going to use what we solved for vector A and B to solve another problem. So let's erase all of this and write down what we know. Okay, so with the vector A, the y component, or the x component of vector A, we can represent that with fax. That just means we just added an A because we're talking about vector A. We said that was 4.5 newtons positive. Y component of vector A was negative 7.8 newtons. The x component of vector B was negative 4.5 newtons. And like with vector A, the y component was negative 7.8 newtons. That's what we know. So what can we do? We have it looks like Isaac Newton painting. So let's draw out the vectors. So that's already done on the sheet I have. I don't know if it's already done for you, but both vectors put together looks like this. So 9 newtons over here, 9 newtons over here, and then here and here, it's 30 degrees, and then x components are negative 4.5 newtons, positive 4.5 newtons, and look, this is the same line, that's why they're both negative 7.8 newtons. What can we do? What are we supposed to do? So it said draw a free body diagram of the nail. The nail of that painting that's shown is located right here. So we write N. Wait, free body diagram. Well, oh, sorry. So free body diagram, I almost forgot about that. So here's the free body diagram, review of 2.1.3. There's a force of gravity down. There's a friction force to the left and right that have 9 newtons. Ooh, that's too high up, sorry. Let's talk about that. We have those measurements. Why? Because of the vectors. The forces are in the opposite directions. That's why there's 2 forces right there. So that's the free body diagram of the nail. Now, we need to find the resultant force. So what is that? Basically, we need to add together the x and y components and then add that into a triangle and find the hypotenuse of it, which will be the resultant force. So let's see. First, add the x components. Here's 1, here's 1. When you add those 2 components together, the sum of the x components, we use, oh, that's not good. We use this Greek letter, sigma. The sum of the x components are 0 newtons because they cancel out. Plus 4.5 minus 4.5 equals 0. Sum of the y components is negative 15.6 newtons. So negative 7.8 minus 7.8 is negative 15.6. So there we go. We have those two. Now, on the coordinate plane, we can draw this. So we have 0 newtons to the left or right. So basically, this is just plus or minus. So that means we don't go anywhere. There's no distance for the x. Then we go down 15.6 because of the y component. Sorry, I'm starting to get a little tired. That's why I'm doing that. And then if it was not 0 for the x component, we might draw it out this way or this way, but that's just not what it is. So we don't do that. And that actually makes this easy because we need to find the hypotenuse. We use a squared plus b squared equals c squared. But we already know that the resultant force has to be the same as the y force because let's just see. So a, let's say that the x component is a. So that's 0 squared plus negative 15.6 squared equals c squared. That turns out to be, it ends up being 243.6 equals c squared. And you take the square root, and you just get the same thing again. But this time, since we're doing the square root, the answer would be plus or minus, because it could be either one. So that is what the resultant force is for number 10. That's number 10. We have one more vector problem to do. So, I'm sorry that this video is so long, but let's go ahead and do that. I'm going to go a little bit quicker for this one, for time's sake. Hopefully, if you saw that, I'm not actually going to write it out. I'm just going to tell you the answer for the things. So, we have, it's a screw, and it has two tension forces that are 150 newtons and 80 newtons. So let's see, what is... Okay, so drawing out the vectors. So there's vector G and H. Vector G is this. It's 150 newtons. And that angle measurement is, what was it? 15 degrees. Then we have vector H that is down here. It has 80 newtons of tension force. And then it has an angle of 20 degrees. And they want you to find the x and y components. So, to find the x and y components, we remember those equations. Force times sine or times the cosine of an angle. So, to find the x component, we need to use sine. We used sine because, well, let me draw this out. So, that's the of g, so let's write FGY. And then, oh, that's too high up, so sorry, I'll have to do right here. FGX. Then we have FHY. And then FHX. So, why did we use sine? Because the angle is across once again, from the x component. And we end up getting for FGX, we get 38.8 newtons. Positive because it's going right. Then FGY, we use cosine because it is adjacent to the angle. So that's 144.9 newtons. And positive because it's up. So upright. For both of them, it's upright, so it's positive. Now, over here, we have FHX. We, this time, have to use the cosine for the x component. Because... Oh, I actually drew that wrong. I'm sorry. You probably noticed that before I did it. I don't know how I can erase that. Okay, let's try to... Oh, still in the eraser. So this is the x component. This is FHX. This is FHY. And this time the x component is adjacent to the angle. That's why we use cosine this time. So it's not always like that, I told you. So it turns out to be 75.2 newtons. And then for FHY, we get, because we used a sine for that one, because the y component is across from it, or opposite, so we get 27.4 newtons. There we go. We have the x and y components. We need to add them now. Or so that the what am I trying to say? The x components. This and this. Not these two. The x components. So when we add 38.8 plus 75.2, we get 114 newtons. Now, sum of the y components, 144.9 plus 27.4, 172.3 newtons. So now, if you use the components of a vector, what mathematical relationship can be used to find the magnitude of a vector? The Pythagorean theorem is what you would use, because that's what we're about to do, to find the resultant force. That's how you can find the magnitude of it. Now, this time it's going to actually be a problem that that it's not going to have a zero length. So we actually have to solve for the Pythagorean theorem, sorry. Unlike the one with the Isaac Newton painting. So let's go and draw this. The x component, we said the sum of that was 114 newtons to the right, because it's positive, or it would be to the left. Then up, positive 172.3 newtons. And then we're trying to find this length, which is the resultant force. Last time, remember, we went down, but we couldn't go right or left, so that's why it ended up being the same as the y. But that's not the case this time. So, Pythagorean theorem. A squared plus b squared equals c squared. A and b could be either of those, but we'll just say x is the a, and so that's 114 squared plus 173.2 squared plus, equals r squared, which we can say c squared, but that's the same. We're solving for that. So now, as you solve that, you eventually would get r equals 206 plus 0.6 newtons. For time's sake, I wasn't going to do that, but you just would square it, then add those two things, then square root it. That's what you do. But also, let's see. Oh, it wanted us to calculate the magnitude and the angle of the vector. That's this angle. What can we do? What can we do? Oh, we have to use tangent because we're going to do opposite over adjacent because those are two values we originally knew. So tangent of angle theta equals opposite over adjacent. That would be 172.3 divided by 114. But that's not the answer. We have to, because after we would do that, then we would just get that the tangent of the angle equals that. That's not what we want. So, in other words, now we have the equation set up as this. We're not trying to find the tangent of the angle, we're trying to find the tangent. How can we get rid of tangent? Because that's not what we're trying to find, only the angle. We can't divide it, but we can negative first it, kind of like that. So we take the tangent to the negative first of 172.3 divided by 14, and we get 57.4 degrees for that angle. There you go. Now, conclusion questions, finally. Although these ones take some time also. I cannot tell how long this video has been recording, but thank you for bearing with me if you're still watching. You may have skipped ahead if you knew it. But, we have the conclusion questions now. So it says, you and someone else are pulling forces at equal magnitude. You're pulling at an angle of 25 degrees from the x-axis. How could you reduce the amount of force that you must exert? Okay, let's draw this. So that's the sled. This is the x-axis. Here we have this and this. 25 degrees, 25 degrees. What could you do to reduce the amount of force you have to exert? Well, the amount of force could be reduced if the angle is decreased. Well, think about it. Let's say you have 9 newtons of force here and 9 newtons of force here. If the angles were decreased, so let's say now we have 3 degrees, 3 degrees. This value would be lower. Using the equations we know, we can figure that out. That's not what I'm going to do for time's sake, because that's not even what the problem asks you to do. You don't have to do that. All you have to say is the amount of force could be reduced if the angle was decreased, because you wouldn't have to pull as much if the forces were acting together, if the angles were closer together. Now, the second conclusion question is, you and someone else are pulling on an object with forces of 50 newtons and 75 newtons, respectively. You are allowed to pull in any direction. What range of values is possible? Okay, let's draw. Well, let's see. So, what values could you, of force could you pull? Using what we knew from the last thing, the force can be decreased if the angle is. So the most would be if it was 90 degrees. That's the most possible thing. So we have 50 newtons and 75 newtons. If we add 50 plus 75, we get 125 newtons. that is the most force. That would be if they were completely in opposite directions. But they are in the same direction, then 75 minus 50 is what we would do to get 25 newtons. And that means that the values could be anywhere from 25 to 125 newtons. And there you go. That is activity 2.1.4. Thank you for bearing with me on this, probably the longest video I've done. But hopefully it helped, and that's what matters. So thank you for watching, and I will see you on the next video, lesson 12 on moments. Thank you for watching.